Okay, we're back. We're going to talk now about some of the vocabulary terms in regards to the gastrointestinal system, and that's what we'll be talking about now. Okay, some of the vocabulary terms. Let's talk about those. Hopefully, you've already gone over the word roots, prefixes, and suffixes, and here we go. Let's talk about these. First, the word that we have there is absorption. Okay, absorption is, we mentioned this a little bit before. With absorption, when we eat food, food has to be broken down into microscopic size, sizes and sort of molecular type of a size. Then what happens is the wall of the intestine has a thin membrane around it, and it has multiple little fingers. We'll talk about that. It'll come up later on as a vocabulary where they're called villi. And what that does is it increases the surface area on the inside of the intestine. If you took a piece of intestine and you open it up, it look nice and smooth. But if you look at it under the microscope, there's all these little fingers. Inside of those little fingers, there's small little capillaries. Now we all know what a capillary is because you've already got through the cardiovascular area. Little capillaries are up inside there. And now the food that's been digested into small enough molecular particles are able to actually go through the wall of all those little fingers, those villi, and get into the capillaries to get in the bloodstream. And that's what we call absorption. So when we absorb these nutrients through the wall of the gastrointestinal system, that's called absorption. Amino acids. Amino acids are basically molecules that are the building blocks of protein. What a protein is, it's a series of amino acids in either a chain or a big clump or something like that. So the amino acids are basically what makes up protein. The way our body makes protein is that code for writing protein is in our DNA. And then what happens is when I need certain proteins, the DNA says, okay, here's the recipe. That's how we make the protein. And they dip into an amino acid pool and start to put the proteins together in a string or a clump, and they fold and stuff like that according to bonds. And that's what creates a protein. Our diet that we have is certain amino acids that we have. Some people who have a very strict vegan type diet, they might be short of some only animal that provide amino acids. They might have to take some supplements because of that. But the amino acids are basically the building blocks of what we call protein. Amylase. We talked about this before. If a word ends in ASE usually means an enzyme. Amylase is an enzyme that breaks down starches. Okay, there are different types, there are different forms of this, but amylase is an enzyme that breaks down starch. Starch, basically sugars and stuff like that, are called starches. Okay, and that's amylase. Anus. Do I really have to talk about that? Anyway, we know that that's the end of the road. There's a sphincter at the tail end, basically that holds fecal material in the rectum, and then finally, at a certain point, when it's time to go eliminate that material, basically that sphincter opens and the material, the fecal material is extruded out through the anus. So basically that's what the anus is. Appendix, everybody knows what an appendix is. Even if you don't know what an appendix is, you know what it is. That sounds strange, but that's probably true. Oh yeah, you had appendicitis. Appendix is sort of what we call vestigial. I mean, it may have had a purpose there, way in the past, but has no purpose now. And basically it's a blind tube. It's at the very lower portion of that cecum. We talked about the cecum as the very beginning of our large intestine. And it really does nothing. We could live very well without it, but it's there. And what happens is then in some situations, seeds, husks, things that don't get a lot of cellulose that don't get broken down really well, they get jammed down in there, and bacteria get in there and they go a little bit crazy, and that's what causes infection. That's what causes appendicitis. So that's what the appendix is. It's in my right lower quadrant. Everybody should know what that is because we talked about that before. Okay, bile. We mentioned bile a little bit in our last talk, and bile is basically a material that's stored in the gallbladder. And whenever someone eats a fatty meal, it causes the muscle in the wall of the gallbladder to squeeze like a tube of toothpaste, and it squeezes that bile out through what's called the common duct. Okay, and eventually it empties into the duodenum. And what bile does, it helps to emulsify fats. It breaks fats down, it liquefies them so they could be more easily absorbed down the road. We know bile is actually made, it's a byproduct, an end byproduct of breaking down red blood cells by the spleen, like we talked about last time. Spleen takes the red blood cells, breaks them down, puts the iron back into circulation, but then takes the protein, sends it to the liver, and the liver creates something called bilirubin, which is a brownish yellow pigment, which is what's the cause of jaundice. When we get jaundice again, that bilirubin accumulates in the skin. What happens is that bilirubin is combined with a couple other things, cholesterol and stuff like that, stuck in the gallbladder, and that's what bile is. So that's what bile. If somebody has a gallbladder episode, like I mentioned in the last talk, then what happens is if they have a stone or if there's inflammation, and that duct that leads from the gallbladder into the duodenum is blocked or swollen, you eat a fatty meal, the gallbladder squeezes, but it can't get past that area of the duct that's swollen or blocked. And as a result, that's when they get that colicky pain. It comes in waves. It gets bad, backs off, gets waves, backs off, gets waves, backs off, because that gallbladder goes into spasm and try to squeeze out and says, I can't, no, I got to relax a little bit. I can't, no, I got to relax a little bit. And if it doesn't, we don't get the bile in there. That's why the stools have a tendency to be fatty, which we talked about last time. It's called steatorrhea. And also because that bile is what actually one of the reasons why we have the discoloration of the brownish color of fecal material, the stools become very clay colored. Okay, and bilirubin, like I mentioned just a second ago before I talked about bile itself, is that precursor to bile. It's basically that brownish yellow pigment. And again, what happens is if people have liver problems where they can't coordinate and I could probably talk for about an hour about this in regards to what's called unconjugated bilirubin conjugate, but that's beyond what we need to know. But what happens if the liver can't handle the bilirubin in one of a number of different ways? Either the cells of the liver don't work, or maybe to be able to make it to a place where it's water soluble, that's beyond what we need to know. Or if there's a problem with a blockage somewhere, the bilirubin builds up in the blood. When the bilirubin builds up in the blood, it leaches out of the vessels, and that's what stains the tissue a yellow color. Bowel is just another sort of more of a layperson's term for intestine. Small intestine, small bowel. Large intestine, large bowel. That's all it is. Canine teeth. Canine teeth are these pointed ones that are here, and a couple on the top, a couple on the bottom. And they're called canine because they look like the big fangs on your dog. If you have a dog, I like dogs. I have a dog. I had a dog a long time. But anyway, it's like those big fangs that they have there. And what the canine teeth are is basically these canine teeth are rippers. In other words, when they dig into something, they're able to tear it apart. I remember once I was playing with my dog and playing with a pull rope and stuff like that, and he tried to grab on, and he grabbed with his canine, grabbed my finger and made a huge hole through my finger. And it took a while for that to heal, but he still loved him. What the heck? Anyway, so those are the canine teeth. They're rippers. Those are the big pointed ones that we have there. Okay. Some more vocabulary terms. Cecum. We talked about the cecum before, and the cecum is that first portion of the large intestine. When the ileum, or the last portion of the small intestine, empties into the cecum, the first portion of the large intestine, there's a little area on the bottom, a little pocket below where it falls down, or a little pouch below where the small intestine comes in, and that area is called the cecum. Right in the bottom of the cecum is right where the appendix is. Okay, so that's the very beginning portion of the large intestine. The colon, just another name for large intestine. The common bile duct. Okay. Now, let me see if I can draw this on the side, and it might be able to help you a little bit. What happens is, let's draw a liver up here. Let me see if I can draw a liver. I'm not going to be very good. I didn't want to do that. Let me use a different color. Get out of there. Okay, let's get rid of that. Let's try this. Okay, let me try drawing a liver. Let's draw a liver here, and let's say this is the liver, like this. Sits like that. Okay, and then the bottom of the liver is my gallbladder. My gallbladder is stuck to the bottom of the liver right here. I wanted it to go green. It's stuck right here, okay? What happens is it's like a sac, like this. It has a tube that comes out of it. Actually, the tube wiggles around this way and comes this way, okay? But that gallbladder, this part right here would be where we see right here peeking out underneath the liver. What happens is then the liver has what we call hepatic ducts, okay? Now, we have a hepatic duct coming from the right side of the liver, and we have a hepatic duct coming from the left side of the liver, okay? So that's called the hepatic duct. They're in red. What happens is they join together. And when they join together, they form another duct, which is called the common hepatic duct. One duct that's called the common hepatic duct, okay? Comes on down. It's much shorter than this, but I have to try to get close. Comes on down, okay, from the liver. What happens then is this bile duct, or this is called the cystic duct, this area in here. The cystic duct joins with that common hepatic duct. The word common means two things or three things or four things joined together. They have something in common. They're all merged together. So now my cystic duct right here joins my common bile duct. And what that does is that creates another duct that comes out this way that goes into the duodenum. The duodenum would be sitting right here, goes into the duodenum and at this point, and this little blue area is called the common bile duct. Well, I just erased that common bile duct. Okay, so that's what that common bile duct is. It looks like a little kid's drawing these pictures. So just to review that, what happens, I have a duct over here from the liver, the right liver and the left liver, right hepatic duct, left hepatic duct, okay, right hepatic duct, left hepatic duct. They come together and they form a common hepatic duct right here. The common hepatic duct meets the cystic duct and creates down here what we call the common bile duct, and that empties with all the pancreatic juice, or the gallbladder, the bile from the gallbladder gets emptied into the duodenum. Okay, so that's what that common bile duct is all about. Defecation. Defecation is just another word for having a bowel movement, having another bowel movement. That's called defecation. Deglutition. Deglutition is a really fancy word for swallowing. When somebody swallows something, it's called deglutition. So deglutition, swallowing, defecation, passing fecal material or having a bowel movement. Dentin. What happens, the teeth are multiple layers. On the outside of the layer, we have what's called enamel, which will come up in a little bit on the next slide. But inside that, we have what's called the dentin on the inside, and that sort of like provides the basic mold for the tooth. That the enamel sits on top of the dentin, okay, and that gives the tooth its shape. Digestion. Digestion, we know, is a vocabulary word that means that what happens is the food that we eat is broken down, and it's broken down to smaller particles, so it could finally get to the area of the small intestine where it can be absorbed. But before it can be absorbed, it has to be digested. What digests it? Acids, enzymes, and various other chemicals will help to break things down, as well as muscle action. The stomach actually has a number of layers of muscles, and what they do is they all work in different directions. So it's like taking a loaf of bread or a piece of some dough that you're going to make bread out of and kneading it, and that's what the stomach also does. So it's mechanical as well as chemical ways, processes that they're able to break the food material down into molecular-sized things that can be absorbed. Duodenum. The duodenum is the first portion of the small intestine. It's only, like I said in the last lecture, about 9 to maybe 12 inches long, very, very small. But a lot of things happen there. The pancreas empties enzymes in there. That what we talked about, our common bile duct empties into the duodenum, and there's a lot of things go on in the duodenum in helping in absorption and digestion. Elimination. Elimination is just another word for defecation. Things are eliminated, things are defecated, okay? Hopefully I don't have any questions about this. Let's go to some more. Emulsification. Emulsification is what we see with fat. Fat, if you try to mix fat or oil with water, it doesn't mix, okay? Fat will float on the top of the water because it's lighter. The oil sits on the top, and you put some cooking oil in a glass of water, the oil will rise to the top. What happens is emulsification is taking that fat or that oil and breaking into such small particles that they could actually be sort of like liquefied. They could be made into a liquid, okay, or blend with a liquid environment, okay, so they don't sit like droplets in there, and that's called emulsification. Bile is really important, helping to emulsify fats once I get the fats in my small intestine. Enamel. I mentioned this in the last slide. Enamel is basically the outer coating of the teeth, that's sharper, the shinier area, the harder area on the outside. As people get older, they wear the enamel off just because of chewing. Things that have a lot of acids in them that you eat, colas and stuff like that, they have a tendency to wear the enamel off. So as people get older, the enamel gets worn off a little bit more, which makes the teeth a little bit not quite as hard. And as a result, you see a lot of these toothpaste now restore enamel, pro enamel toothpaste and stuff like that to try to help it come back. I don't know what happens, but anyway, that's enamel. It's the outer like shell on the outside of the tooth. An enzyme, like we talked about, is a chemical that will break things down. Now we have amylase breaks down starch, lipase, lipo means fat, lipase breaks down fats, and proteases break down proteins. So if you see ASE as a suffix at the end of a word, think it's most likely an enzyme. There's tons and tons and tons and tons and tons of different types of enzymes. Most of the chemical processes in our body are actually produced by enzymes that need to be there to help to make that reaction work, okay? And those are what enzymes are. The esophagus. The esophagus is the food pipe. It goes from the mouth, the back of the pharynx, down to the area of the stomach. It goes through the chest and then ends up and goes to the diaphragm where it gets into the stomach. The esophagus is a muscular tube, so it's most of the time it's closed. And when we eat, it'll open and there'll be squeezing of that esophagus to actually force the food down, like milking down the esophagus. So that's what the esophagus is, okay? I'll talk a little bit more about the esophagus and some conditions later on. Fatty acids are basically materials that are fats. They're called fatty acids. Feces, again, we don't have to talk too much about that. We know that's fecal material. The gallbladder. We've already talked enough about the gallbladder. The gallbladder, we know, is that organ that sits right underneath the liver. It's sort of like a little sac, and that sac contains bile, and that bile is for emulsification or liquefying fats. Okay, and that's what we have. Glycogen. I mentioned glycogen a little bit before, and glycogen is basically since we can't store glucose, we have to put the glucose into a form that it can be stored. And what the body does, it takes the glucose and strings it together into a starch material, which is called glycogen. Then that glycogen then can be stored in the liver, and it can be stored in the skeletal muscle. So if I need sugar, the body says, hey, I need some sugar now, and there's not enough in the circulation going around, because again, we can't store it. What happens is then the body can then go to the area of the liver or the skeletal muscle, take the glycogen out and cut it down, and all of a sudden now it releases glucose. Okay, so that's what glycogen basically is. If you're an athlete, you know, oh hey, our swimmer, okay, you probably know about this. Sometimes people do change their diets. What they'll do is they will try to do what's called glycogen storage. And what they'll do is like before an event, especially if they're in endurance events, you know, eat a lot of carbohydrates. And what the carbohydrates do, they're broken down to sugars. The sugars then get made into glycogen. Glycogen gets stored in the area of the muscle and liver. So that way, if you're in a long event, you can't stop like halfway through the event to take a candy bar. You know, have a Snickers. No, you can't do that. And also, if somebody threw like a baby Ruth in the pool, that would be a problem. People would always start to worry. But anyway, this way that now there's an energy store that could last for a longer period of time, and that's called glycogen. Hydrochloric acid. Hydrochloric acid is the acid that's in the stomach, which is a very strong acid. So the question is why doesn't it burn its way through your abdominal wall, your stomach wall? And it does sometimes. And it really why it doesn't in most people is because the body, through a material called prostaglandins, actually makes a mucus. And it's a thick mucus that actually coats the wall of the stomach. And that mucus prevents the acid from getting to the stomach wall itself and burning a hole. So that's what that mucus does. People who take like long-term anti-inflammatories, like high-dose long-term non-steroidal anti-inflammatories such as Motrin, Advil, Aleve, Naproxen, you know, all those. What they do is they have a tendency to stop the prostaglandins, all prostaglandins. Prostaglandins also cause pain. Those are bad prostaglandins. The good prostaglandins open up my airways, my lungs, also creates that mucus. So if I take a lot of these anti-inflammatories, what happens, it stops the production of the mucus in my stomach. Therefore, what happens is now the stomach wall might be a little bit more exposed to the acid that's in the stomach that causes things like ulcers or gastritis. So that's why you'll see a little on the side of an aspirin or anti-inflammatory bottle, not Tylenol. Tylenol is not an anti-inflammatory. But if you look at the side of a bottle of an aspirin or some type of anti-inflammatory, what you'll see is do not take for over a certain amount of time unless under direction of a physician. And that's the reason why is that the anti-inflammatories have a tendency to block the prostaglandins that actually produce the mucus in the stomach, and that causes a problem. You know, and that a lot of people who are taking anti-inflammatories and stuff like that, or anything else that would block the prostaglandins, end up with a lot of gastric problems because of that. Okay, I know that when I used to give patients anti-inflammatories, it got to a point where I also used to give them medication that will decrease the gastric acid production in the stomach, like Prilosec, Prevacid, something like that. Or you could actually give them synthetic type mucus that they could, you know, a thing that will make like a mucus in the stomach, but that's still above and beyond. Okay. Let's get to some other ilium. Okay, ilium we know is the third portion of the small intestine. Duodenum, small, jejunum, long, ilium, long, and it's that order. And I'll tell you what, the ileum is really important because a lot of things happen in the ileum. It's probably one of the more common places for Crohn's disease to occur, and a problem. We'll talk about Crohn's disease when I talk about some conditions down the road. But the ileum is the third and the last portion of the small intestine. Incisors. Incisors are the front teeth. The two on the top and the two on the bottom, actually four on the bottom. They're actually, we have, two here, and then canines, then a row of very sharp teeth on the bottom. And their incisors means to cut. And so what happens, these teeth come to, instead of coming to like a point, like a fang, they come to an edge, like an edge of a knife. And basically that's what their purpose is. When we bite things off, we bite them off with the front because those are the incisors, and they just sort of slice right through the material. Insulin. Insulin's a hormone, and the hormone is put out by the pancreas. When I eat food, what will happen is there's a signal that goes to the pancreas, and the pancreas says, make insulin, because I need insulin to get glucose inside the cell. The glucose gets in my blood, goes around, but it can't get in the cell. The doors are closed. Glucose is a very simple, small molecule. But to be able to get the glucose in the cell, I need insulin. And what insulin does is when the pancreas releases the insulin, it circulates throughout the whole body. And then what it does, it goes to all the cells and binds to various receptors on the surface of the cells that open up a door, that allow a door to open to let the glucose get in. That's why people with like type 1 diabetes, when their pancreas stops making the insulin, which is also autoimmune, their antibodies actually destroy the cells in the pancreas that make the insulin. What happens in the case of diabetes type 1, the insulin is not there, so they can't get the glucose in the cell. They have to use other things like fats, which then becomes a problem. And people have known people with diabetes, they talk about diabetic ketoacidosis, because the byproduct of breaking down fats are called ketones. These ketones are acids, and it changes the acidity of the blood. The blood becomes much more acid, which then destroys our homeostasis. It doesn't work very well. So insulin is really important. We can't give insulin by mouth right now because what happens is the gastric acid destroys the insulin. That's why it has to be done by injection. Other medications that are taken by mouth are not really an insulin, are not really the typical type of an insulin. What they do is they make the body do other things to handle the sugar in a different way. That's what they do. Jejunum, I mentioned that's the second portion of the small intestine. Again, duodenum, jejunum, ileum, okay? Lipase. ASE, enzyme, fat. Lipase is an enzyme that breaks down fat. The liver. I wish I could spend like 3 hours on the liver. Maybe I will someday. I'll just do a liver talk. Liver is such an important organ, and people don't give credit for it. Number one, everything that's digested and absorbed in the small intestine, the first stop on the train, the liver, goes to the liver. And the liver sort of manages and handles things around and moves things around. Liver is important in activating medications, deactivating medications, activating various things, making clotting factors, working with producing some vitamins. There's just so many things. It helps to make the bile, because it's what really puts together the bilirubin. It has about 1 billion different functions, but it's important in the case of the gastrointestinal system simply because it is the first step, or the second step really, because the spleen is the first step. The second step on the line in regards to making bile, which emulsifies fats. Lower esophageal sphincter. We talked about this in the previous talk, where what happens is when food comes down the esophagus, what happens is at the bottom of the esophagus, right where the esophagus goes to the diaphragm, and right where it meets the stomach, there's a sphincter. Now, I mentioned a sphincter, and I think this is important to know. Sphincter is a ring of muscles that's around a tube. If those muscles relax, the tube opens. Okay. If the sphincter, I gotta get over here. There you go. If the muscles contract, the sphincter closes. So when I eat food, the sphincter stays open. I get the stuff in my stomach, then the sphincter will close. Okay, so that's the lower esophageal sphincter. One of the problems we have in what's called GERD. GERD stands for gastroesophageal reflux disease. The sphincter doesn't close, and the acid, particularly at night when people are lying flat, the acid comes out, leaks out of the stomach, and gets in the lower esophagus, which causes an irritation and that heartburn. So that's the lower esophageal sphincter. Mastication. Mastication is just another word for chewing. So when you masticate something, and if you take anatomy and physiology, you'll talk about muscles of mastication, which are chewing muscles, temporalis, masseter, and the pterygoids, which make our jaws go back. Molar teeth. The molar teeth are the crushers. They're the ones in the back. They're flat in the top with little bumps. And what they are is they're basically crushing teeth. They take the food, they jam it between the two, and they crush it between the two, and that's what the molars do. So the molars are starting to help to digest in the mouth by crushing things up so that the enzymes, the amylase from the parotid gland could start to work on that, and then mushes it up so you have a mash so I could put it together with the saliva so I could swallow it so it would get down to the stomach for more extensive digestion as well as in the small intestine. So that's that list. A couple more words here. Palate. Palate is basically the roof of the mouth. Okay, the roof of the mouth is called the palate. Okay, I don't know what's happening to my cursor here. It's called the palate. There we go. I got it. Is a palate. So the roof of the mouth. The front of the mouth, the front 2/3 of the mouth is very hard because that's bone underneath there with just a little skin. That's called the hard palate. No duh. And then behind that, it's soft. It's called a soft palate. And soft because when I swallow, that soft palate will rise. If you look inside your mouth with a flashlight and say, ah, you'll see that soft palate rise. It seals off the back of the nose. So when I eat, things don't come out my nose. Okay, they go down the esophagus. There's only one way to go. The pancreas. The pancreas is an organ that's behind the stomach. It has a duct that leads right into the area of the duodenum, right either with or very close to where the common bile duct goes into the duodenum. And the pancreas, besides an endocrine function, making the hormones such as insulin, which lowers blood sugar, and another hormone called glucagon, which raises blood sugar, also makes a number of enzymes. Particularly another form of amylase is made in the pancreas, as well as lipase is made in the pancreas. And when people have pancreatic disease, a lot of times what they'll do is they'll actually follow their blood levels of amylase and lipase, which actually increase in the blood because they're not being put into the duodenum. They end up with higher concentrations, therefore they get more in the blood. So that's the pancreas. The pancreas is a really important organ. I'll talk more about that later on with pancreatic carcinoma. Papillae. Papillae are little bumps. If they look at the tongue has small little papillae on there, which are basically, we call them taste buds, but the taste buds actually have sensory receptors in there, but they're in papillae. Okay, so that's what the papillae are. Parotid gland. At the angle of my jaw, right here, where the jaw comes, where the mandible comes to an angle, there's a gland that sits over the top of that, and that's called the parotid gland. The parotid gland actually makes saliva as well as makes amylase, which is an enzyme that also will break down the starch in the mouth. If you go home tonight, or if guess what, you are probably home, unless you're at, well, no, you can't go to Starbucks and sit there on your computer, at least now. But anyway, if you take your finger and you pull back on your cheek and you look up to see your second upper molar, you might see a little bump, and that's where the parotid gland duct actually empties that saliva and the amylase into your mouth, and that's called the parotid gland. Okay, when people have mumps, it's an infection or inflammation, a viral inflammation of the parotid gland. Okay, peristalsis. Peristalsis is like a muscular wave-like contraction of my intestines. So what happens is to move things around. Sometimes the intestine is going to go up, sometimes it's going to go down, sometimes it goes left, sometimes it goes right. It twists around, goes forward, backwards in all different ways. There's no rhyme or reason to how the intestines basically sit. Maybe a little bit because it's held by what's called the mesentery, but it sort of sits back in there. But it moves. The intestine is freely movable inside the abdominal cavity. And what we'll find is that to move things in the intestine from one area to the other, the muscle of the intestinal wall will squeeze in a wave-like form, like a milking action, and that's called peristalsis. When you're sitting there and you hear that stomach gurgling, that's basically peristalsis. Pharynx. Pharynx just means the throat. So when you think of the throat, that's called the pharynx. The portal vein. Oh my gosh. Here we go. I could go on for about 3 hours just on the portal vein alone. And the portal vein is, if you've taken anatomy and physiology, I always ask people who have taken anatomy and physiology, how much do you know about the portal vein? And they'll give me this, oh, what, me? I don't know anything about it. And because a lot of people don't talk about the portal vein very much. But I mentioned before that when I absorb things through the intestine, it goes into small little capillaries. These capillaries then start to go into venules, larger veins. And what happens is that the vein that drains most of my small intestine and the first half of my large intestine is called the superior mesenteric vein. Superior mesenteric vein, okay? It's a pretty large vein. And that meets with another vein that comes from the spleen called the splenic vein. And it creates what's called a large vein, which is called the portal vein. That portal vein then takes everything, goes to the liver, right to the liver. Well, what did the portal vein do? It took all the things that were absorbed, all the nutrients that were absorbed in the intestines, okay, in the small intestine and the first portion of the large intestine, puts it in the portal vein and takes it to the liver, because the liver is responsible for taking care of all that, shifting it someplace, making things out of what comes to the liver and stuff like that. So that's called the portal vein. I could go into that. I love talking about the portal vein. I could go on for hours and hours and hours about problems with the portal vein and stuff like that, but we don't have the time here. Protease, ASE enzyme. Protease means an enzyme that breaks down protein. Pulp. Pulp is sort of like that central core of the tooth, where the roots and the vessels are in the center of the tooth. When they do like a root canal, basically what they do is they go down, they hollow out, and then core out that pulp area, and then fill it with the material. So the tooth stays viable. Otherwise, the tooth will die from inside. So that's the pulp. It's the center, the softer portion. Pyloric sphincter. I mentioned this the other day. What happens is the pylorus is the end of the stomach, where the stomach is going into the area of the small intestine to the duodenum. It goes into an area called the pylorus. The pylorus is sort of like a funnel-shaped area. So the material in the stomach, the sphincter opens up to let the food go, or the food, I wouldn't eat it again, but the material coming out from the stomach and into the area of the duodenum, and that's called the pyloric sphincter. I mentioned that briefly on my last thing about people who have projectile vomiting. When this pyloric sphincter goes into a spasm, the stomach just fills up and eventually things come crazy out, okay? Like shooting like a under high pressure. Pylorus, again, that's the end of the stomach where it funnels out through the pyloric sphincter. Rectum is basically the place at the end of the large intestine, heading downwards towards the anus, between the sigmoid colon and the anus, basically a place to be able to store fecal material. That's all the rectum does. Rugae. Rugae is basically, if you looked at the stomach, on the inside of the stomach has all these folds. Okay, and all these folds. If you look with a scope, you see all these folds on the inside of the stomach. And what those folds actually do is there are about 4 layers of muscle in the stomach, and they all go in different directions. And when they're all contracted and when they're all like narrowed down, basically it causes these little wrinkles, sort of like those squinchy things that girls wear in their hair. If you just leave it, it's very wrinkly. But if you take it and stretch it out, it gets smooth. So what this rugae do is, first of all, they guide mucus to go through the stomach into various areas. Plus, when we eat, because the stomach muscle or the stomach wall is able to expand a lot, there's a little room for expansion because those rugae now become straightened out. Okay, and that's called rugae. Saliva. Saliva is basically the material that we produce by the salivary glands in my mouth to help to create a moist ball of material that I can swallow. And how do we make saliva? The salivary glands, the glands. There are a number of glands underneath the tongue, as well as the prod gland are all salivary glands. The sigmoid colon. I mentioned that what happened before is, if I look at the colon goes up, ascending colon goes across, transverse colon, and goes down. However, I know that anus is sitting over in here. So what happens, I have to get from here over to here, from one spot over here to this spot over here, and it goes through this S-shaped curve of the colon, and this area right here is called the sigmoid colon, because it looks like the Greek letter sigma, which is sort of like that. Okay, so that's the sigmoid colon. Sphincter. I mentioned sphincter multiple times, and sphincter we know is like just a ring of muscles around a tube. If the sphincter's open or relaxed, things go through. If the sphincter contracts, the sphincter closes and nothing goes through. Stomach. Stomach is a place where it's basically the first area of major digestion. We start digesting in the mouth with the amylase, but there's only a little bit. Esophagus is only a tube. It's a chute. That's all it is. But when I get in the stomach, that's where the big time digestion starts. Acids, enzymes, all kinds of different things and chemicals that are starting to break down the food, and that's what the stomach is all about. Triglycerides. Triglycerides are basically one form of fats, okay? And we see sometimes when they actually look at people's blood fats, they look at the triglyceride levels, but triglycerides are fats. Uvula. Uvula is that little thing that hangs at the back of the throat. We talked about that the other day. It doesn't have the size, the shape doesn't have much difference. It's basically where the muscles and the soft palate come together. There's a small little muscle tab there, which is called the uvula, covered by the mucous membranes. Villi we know are the small little fingers I talked about inside the intestines, and the little fingers increase the absorption area, or the sort of like there's more areas where things could be absorbed, and that's what the villi do. Hepatic duct, I talked about that before. The hepatic duct is a right hepatic duct and left hepatic duct come together to form the common hepatic duct, and that common hepatic duct forms and joins with the cystic duct to become the common bile duct. Quack, quack. Okay. Now, we're going to stop here with the vocabulary. I got some of the conditions that I want to talk about in another video coming up. Probably have one more video on the GI tract that hopefully maybe I'll do tonight, or if not, I'll do it tomorrow, but that'll be put up on Blackboard pretty soon. But we want to talk about conditions, simply because it's going to take the word roots that I had plus all the vocabulary words and put it together in a context that'll help you understand those things just a little bit better. So we'll talk a little about conditions a little bit later. So we're going to stop right now. Hopefully you learned something from this presentation. And again, more to come. Okay, we'll talk to you again soon. Hope you're watching these. Hope you're enjoying them. Hope you're following me. And again, you can watch them as many times as you want. If you can't fall asleep, put it on your phone and watch on your phone, and I guarantee you'll be asleep in about 5 minutes. Okay, bye-bye.